So we're going to go over the difference between series and parallel. So to find the equivalence resistance, so these are with resistors, and then we have voltage in our circuit. To find the parallel, so when things are in parallel, it's going to be 1 over the equivalence is equal to 1 over our resistance plus 1 over our resistance plus 1 over our resistance, so on and so forth. For parallel, it's going to be it's just going to be our equivalent resistance is equal to our resistance plus our resistance plus our resistance. So now, just to draw how to determine what's in series versus what's in parallel, we will start with series. So if something looks like this, resistor, let's say this is our volt. So these are volts. This is resistance 1. This is resistance 2. Resistance 1 and resistance 2 are in series with one another. The way I look at this is if you go from high to low voltage, and you move the volts move along these resistors. In order to get from point A, the start, to point B, the end, it has to travel through both resistors. So anytime it must travel through both resistors, it's in series. So this is our series, and then our parallel would look like this. Then our resistance would be like that. So there's our volts, resistance 1, resistance 2, resistance 3. So this is point A, this is point B. We can travel through this way, or we can travel through this way, or we can travel through this way, but we're never going to be traveling through two of the same resistors. So here you would add the resistances. Here you would add the 1 over the resistance, and then take the inverse of that to find our solution. So if this was resistance 1 was 5, resistance 2 was 3, then our equivalence resistance would be 8 ohms, and that's it. This guy, if this was 2, this was 3, and this was 4, then we would do 1 over 2, 1 over 3, and then 1 over 4. We would add all those up, and then we would take the inverse of that. So our equivalence resistance would be 0.92 ohms. So super straightforward when you look at it like this, but it gets a little more complicated when we are looking at it in series and parallel in the same circuit. So something that's in series and parallel, we have a mixture of both in a circuit, would look something like this. So we have our voltages, then we have resistance 1, resistance 2, resistance 3, resistance 4, resistance 5, so this is a little bit trickier. So, and then this is resistance 6. So how would we go about this? Well, this is in series, this is in series, this whole thing's in series, and this is in series, but this thing's in parallel with itself. So we know that this would be a super easy one to solve if it looked like this instead. So if it looked like this, that would be super easy to solve, because we would do this plus this plus this plus this, and that's our answer. However, this little chunk is what makes it complicated. So if we can just add this and make it look like this, then we're good. So let's just solve this. So we're going to say this is 3 ohms, this is 2 ohms, this is 2 ohms, 3 ohms, 3 ohms, and then we'll go 5 ohms. So we know that it's going to be 3 plus 2 plus, we don't know this yet because that's complicated, plus 5. So we got to sort this out so that it looks like this. Well, these are in parallel with one another because it could go through here, it could go through here, or it could go through here, but it's never going to go through 2 of them or 3 of them. It'll always only go through 1. So to solve this, this is just all in parallel with one another. 1 over the equivalence here is equal to 1 over 2 plus 1 over 3 plus 1 over 3. So we're going to go 1 divided by 3, 1 divided by 3, and 1 divided by 2. Add all these up. Then we take the inverse of that, and then our equivalence is equal to 0.857. Then what we're going to do is we're going to say this just turned into that. So this is 0.857. And then this remains the 3, this remains the 2, and this remains the 5. So 0.857 goes right there. And we're 0.857 plus 5 plus 2 plus 3. Our equivalence resistance throughout the whole thing is 10.857. So it's as simple as that. There is a way that we can do, it can get obviously much more complicated. So we'll do one that's a little slightly more advanced. We're going to go our volts, resistance 1, let's call this 5 ohms. Resistance 2, we're going to call this 3 ohms. Two ohms for resistance 3. Resistance 4 is going to be 3 ohms. And we'll call this 6 ohms. All right. So this is in parallel. This is in parallel. This whole thing's in parallel, but these are in parallel with one another, which is in series with this. So we would again, I always like to draw a simple version of this. What we would do if it was really easy to solve, and that would be, it would look like this. If it looked like this, that would be super easy because we would do 1 over our equivalence is equal to 1 over this, 1 over this, 1 over this. Easy as that. So we have, so far, these two are going to be really easy to find. So we know 1 over equivalence, which is what we're looking for, is equal to 1 over 5 plus 1 over 3 plus, we got to figure this out here. So let's turn this into this. This is what we want it to look like right here. How can we do that? Well, these two are in parallel with one another. So we're going to start by making it look like this. So we're going to change this into this, and then we can change these two into this. So this and this is 1 over 2 plus 1 over 3 is equal to 1 over the equivalence, because these two are in parallel with one another. It can go through this one, or it can go through this one. It won't go through both. 1 divided by 2, 1 divided by 3. Add those up. 1 divided by, so take the inverse. Okay, so this is 1.2. So what is 1.2? This whole thing's 1.2, so we can change it into this. This remains 6 because we haven't manipulated that at all. And then now we just need to add these in parallel, in series, because it goes through this and this. It won't go through one or the other. It'll go through both. So that's just 6 plus 1.2, 7.2. Well, we turned this into this, and then we turned this and this into that as 7.2. So now we can plug this into here as 1 over 7.2, because this is in parallel with this is in parallel, this is in parallel. 1 over 7.2, 1 divided by 5, and 1 divided by 3. Add them up. 1 divided by the equivalence. Our equivalence resistance, 1.4876. That is everything. Yep, that's it.